Okay, let's look at one more of these limits, these exponential limits. So here we're looking again, limit as x approaches 0 from the positive direction. As x approaches 0 from the positive direction of x plus cosine x to the 1 over x. So as x goes to 0 in the positive direction, again, trig function wise, we're in the first quadrant, so positive. So as x goes to 0, that would just be 0. Cosine would be 1, so we'd have 0 plus 1. So the whole thing approaches 1. And of course, 1 over x would approach 1 over 0, which would be infinity as we're in the positive side, positive infinity. So this is going to be a 1 to the infinity limit. So once again with a 1 to the infinity limit. So with all these exponential limits, we always begin by taking the limit of the ln function. Limit as x approaches 0 from the positive direction of the ln of x plus cosine x, all that to the 1 over x. We then use our properties of logarithms to bring the 1 over x out front. That would be then times the ln of x plus cosine x. Okay, so our problem is transformed from a 1 to the infinity now to a 1 over x. As x goes to 0, that would be infinity. Ln of 1 would be 0. We have an infinity times 0 limit. So remember, infinity times 0, we take one of those things over the reciprocal of the other. Well, this is definitely the more complicated thing, so we put it on top. Limit x goes to 0 from the positive direction of the ln of x plus cosine x all over the reciprocal of 1 over x, which would be x. And so that transforms our problem into a 0 over 0 limit. And now we can apply L'Hopital's rule. So we take the derivative of the top. That would be 1 over that stuff times the derivative of that stuff. Derivative of x would be 1, derivative of cosine would be minus sine. And then that'll all be over the derivative of the bottom, which is just x, just be 1. So at this point, cleaning it up a little bit before we start to move forward with trying to work out the limit, this would be 1 minus sine x over x plus cosine x. Now as we observe this, we notice that there is no issue with what's left now. We can actually just let x become 0, because the top would be just 1 minus 0. The bottom would just be 0 plus 1. And so the whole thing is just 1. The whole thing is just 1. Okay, so this one actually worked out pretty smoothly. We only had to use L'Hopital's rule the one time. And so now finally the overall original limit as x approaches 0 from the positive direction of x plus cosine x raised to the 1 over x function is just equal to e to the first power, which is just e. So this thing just approaches e and e only.